Today we are going to deal with the binary number system, and as you know, binary means two, so it means they are those numbers with the base 2, with the 0 and 1, which are called bits. Then you'll be given certain numbers and you have to convert into their binary number system. Like for example, you are given this to convert into its corresponding binary number. And what you normally do is to come and check this one with its place value. You also check this one with the place value, all of them. So once again, what you normally do is you take this one, multiply by 2. Remember, we are saying it is base 2 times its place value. Place value will be ones, tens, hundreds, thousands. So a thousand is with three zeros. Once again, you add to 1, this second one, you are multiplying with the 2. Then remember it will be to power 2 because it is in the place value of hundreds, and you add it to 1 times 2 power 1. Know that it is in the place value of 10. Then you also add it to 0 times 2, then power 0, and you also add to 1 times 2 power. Now, since it is past decimal point, on the other side of decimal point, it will be bar 1. You add 2, it is 0 times 2 bar 2 plus 1 times 2 bar 3. So once again, after taking all this, then you add the final answer that you get will be the corresponding decimal number that will correspond to this binary number that we are given here. So this one, 2 power 3 is 8. 8 times 1 is still 8. Then you add it to 2 squared, you are getting it is 4 times 1, it is 4. Plus we have 2 power 1 is 2. You add it to 0 times the n number, you know it is 0. Then you are adding to this 1 times 2 power negative 1. You are getting it is half. Then you add it to 0 and you add it to 2 power negative 3. You are getting it is 1 over 8. So once again, upon addition of all this, remember 8 plus 4, you are getting 12, that is 14. You are getting 14 plus a half plus a 8, and this one will give us 14 and 3 over 8. This will be our number, our decimal number that maybe we are given. I don't know whether it is a decimal point or as improper fraction or as a mixed fraction. So once again, this will be our answer. You can be given a number in a form of, let's say, like for example, you are given 58. Then you are told to calculate its binary corresponding binary number. Remember, this one is to base 10, but this one is to base 2. So this when it is to base 10, it is called denary, and you just come here, you write it is 58. Then remember you are converting into a binary number. So by means 2, you are dividing with the 2. Then whatever remains, you write it here. So 2 divided by 58, you are getting it is 29. And 29, you are remaining with 0. Then you also again divided by 2. 29 divided by 2, you are getting it is 14, and you are remaining with 1. You divide it 14 by 2, you are getting it is 7, but you remain with 0. You also divide 7 by 2, you are getting it is 3, but you remain with 1 because 3 times 2 you are getting 6. You also divide this by 2 and you get it is 1, but you remain with a 1. You also divide this by 2 and you are getting it is 1 divided by 2, you are getting it is 0.5. So once again, this will be our last number. And on writing on binary, you will write from the bottom here upward. So we will have 1, 1. We also have another 1. We have 0. We have 1. We have 0. So this will be our corresponding binary number system that we have. So this is all about binary numbers, and it is very simple. But for example, you may be given a decimal number like this one, 0. Let's say 8793, like that, or maybe let's put 5 and check whether we will get something. So once again, on converting this into binary number, what you normally do is you multiply by 2 and you ignore the whole number that maybe you will get on this side, and remain with the other side is the one that you will continue multiplying. And for example, let's multiply this. It is 0.8795. We are multiplying with the 2. So upon multiplying, you are getting 10, carry 1, this is 18, we are getting 19, carry 1, we are getting 14, 15, carry 1, we are getting 16, that is, you will get 7, carry 1, we are getting 1. So upon multiplying, you ignore this one, you multiply the decimal part of this question. So let's multiply by 2. We are multiplying with the 2. So this one will not multiply again with the 2. Remember, you are converting it into binary number system. So we will not multiply this one into 2. So once again, we are getting 0, we are getting 18, carry 1, 10, 11, carry 1. This is 14, carry 1. 14 plus 1, we are getting 15. So 15, and this other side it was 0, it will now become 1. Remember, this one you don't have to add the one that you are carried here, you just write it in here. So once again, multiply again with the 2 and check what you are getting. It is 0, you are getting 16, carry 1, you are getting it is 2, which is now 3, 10. So 0, and the one comes on this other side. You also multiply again with the 2 and check what you are getting. It is 0, you are getting 12, carry 1, you are getting it is 7, you are multiplying, you are getting it is 0. So once again, nothing you have carried. You continue multiplying like that, you continue multiplying like that, and you realize that this number is not giving us solution. So this one is 0, so 1, it will remain to be 0. So what you normally do, if maybe you are given a decimal number and it is not giving us a whole number, it is not entering this side of decimal points, it means you have to leave it at reasonable decimal points. You cannot just convert twice like this and then you write. No, 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 no. So what you normally do is you continue multiplying and then you get a reasonable decimal point. That's when maybe you can leave it like that. So let's multiply for the last time. You are getting it is 0, you are getting 8, 8, you are getting 2, then it is 0. So this one, I will clarify on this. On the other side, we say that you write from bottom upwards. But on this side, you'll write just the way they follow, so downwards. And we've started with this one. So we have 0 point, we have 1, we have 1, we have 1, we have 0, we have 0, we have 0. So once again, this is what we are getting. We have decided to go up to 61. Remember that one exactly, at least it's a reasonable decimal point. So that is what you normally do with the decimal numbers if you are converting to binary numbers. So that is all about binary numbers. We shall continue from there.